Hello, my name is Matthew Ong, and I am the project manager for the Discovery Project Spring 2024 titled Building a Semantic Annotation Pipeline for Akkadian. I am a PhD student in Berkeley's Middle Eastern Language and Cultures program studying Assyriology, which is the study of ancient Mesopotamia. And I just want to introduce some of the aspects of this project, which is relevant to some of my PhD research. And then after that, the other project members will talk about what they were responsible for. The project is basically taking a number of morphosyntactic annotations as well as semantic frame annotations of a number of Akkadian texts online and constructing work pipelines which can integrate both of those forms of data in a single platform, hopefully online or accessible for collaboration, and doing all this in a consistent way. So just to explain what the underlying data is, let me go to the ORAC site. This is a online repository of Akkadian texts with a number of projects, or as we call them, corpora, where individuals, researchers throughout the world can basically produce editions of these texts. So among the various corpora, there are multiple documents, and a single document looks like this. So you have basically the Akkadian text in transliteration and translation and metadata. But importantly for the transliteration, the editors of this text have provided what we call lemmas, basically the underlying morphological form of a word across its various inflections, and provided a part of speech. So this is the pre-given data. And what I did before the start of this project was essentially to download a lot of this, multiple corpora, multiple documents per corpus, and to make syntactic annotations or morphosyntactic annotations of all of these texts using the annotator called Inception. So what you're looking at here is basically the same kind of text or documents before, but I've made all of these additions, such as the lemma, the morphosyntactic parse, and then the syntactic relations between them. Notice, by the way, that typically a document is divided into a number of what we call sentences, which becomes important later, but these are conlu sentences, and part of the difficulty or the challenge of the data project is reconciling the data form here in Inception with what is done on the other side, that is in the same for the semantic frame annotations. So what are the semantic frame annotations? Well, this is something which I also did before the project, although I'm still going through it, of using an entirely different web tool developed by the people at the FrameNet Brazil project. And it essentially is a database of semantic frames taken over originally from Berkeley's English FrameNet project, stores it in a single SQL database. Here you have a list of semantic frames. For each frame, you have it's called a semantic role, the types of roles, and importantly, words called lexical units, which are taken to be, if you're reading a text or essentially using language, right? When you speak one of these words, you are effectively evoking the frame in the mind of the listener or the reader. And annotating a corpus for semantic frames means essentially going through the same sets of texts, right? Divided up by corpus, sentence, and highlighting words which evoke the various frames here, right? This is an Akkadian sentence. Highlighting the various the sentence words in the sentence. We would call these forms, and telling which role it evokes, or possibly just, as I think will be discussed later, whether the word simply evokes the frame in general, with these so-called target words. This is an entirely different coding scheme, essentially. The documents are broken up into a kind of sentence, but a different type, called the SQL sentences. And so again, the project has to be, the goal of the project is to integrate this kind of information from the SQL side with all of those conlu files. We decided to store all of this information on a Wikibase project. There are two different forms. There is a online form of these Wikibase projects called Wikibase Cloud, hosted by a group of programmers in Germany. As well as the code is made publicly available for local installation. But regardless of which version you use, a Wikibase project is structured like Wikipedia, essentially. That's what it looks like aesthetically, but the data is structured as a knowledge graph. That is in terms of RDF format. So you can create a bunch of web pages and basically create a number of statements for each of these pages representing, say, a data point, expressing how the various data items relate to each other. So here's an example of a document, like one of those texts you saw before on ORAC with its own title, and then a number of statements defining the kind of data object it is, as well as how it relates to other objects like the corpus, and there are similar data items either for, say, lexical items or even attestations of individual forms across the entire corpus. So with that said, I will now handle things off to the next member to talk about the SQL side of the data.
My name is Ayushi Diokle, and I was one of the students working on this project. I'll be going over how we initially created the Wikibase and the SQL data. Ashley and I initially created the Wikibase using the FrameNet Brazil web tool for annotated words in the Akkadian text. So we first had to manually import the basic data types of frames, lexical units, and corpus annotations that eventually created triple statements. Based on the data types for frames, we created P items or properties to connect these frames and add affiliations. As you can see below, I have a screenshot of a frame called Sending Letter, which had words affiliated with it that had core roles or peripheral roles. We also had lexical units or LU items linked to the frame, such as in this screenshot, Suparu. And we used quick statements on the Wikibase to import these items. On the SQL data side, we took the data for frames for corpora, document sentences, and annotation sets. As you can see here, I have two screenshots, one for the corpora and one for the sentences from the SQL data. And in each thing, they have specific data fields, such as for corpora, they had ID corpus, and for sentences, there was ID sentence. Ashley and I wrote scripts in Python using the Wikibase integrator package to import the specifics of the data into the Wikibase. In addition to this, we also used the Wikibase Sparkle queries to retrieve the affiliated data that was already in the Wikibase to link the corpora, document sentences, and annotation sets together. And we also used it to add the data that was not already added when we first imported all of the data for these frames. More on the annotation sets. The annotation sets represent the annotations made for specific Akkadian SQL sentences. On the SQL ACE data, the annotation sets are recorded with start and end characters, as you can see with this screenshot, which we use to view the annotations. And in the SQL database, Akkadian text is represented through characters.
Hi everyone, my name is Ashley. I'm another student who worked on this project, and as you have heard already, the SQL database has a lot of Akkadian information in there, such as corpuses, lemmas, sentences, and more. And specifically for this project, there was a lot of back and forth involved, especially utilizing overlapping information from various data sets, because this database is extremely large and there was a lot of overlapping information in various columns that we had to be able to reference. So that was one of the main challenges of this project, especially for tackling the SQL database side. So my main focus out of the SQL database options was the lemma form issue. So to give a brief overview of what lemma forms are, we had two that we were working with in the SQL database. So the ones you can see here that are called targets, they were not connected to any frame elements, which are directly a direct pathway to connect with a frame, whereas the non-targets here are connected to frame elements because they evoke a frame. So in this way, initially, we were only able to utilize the lemma forms that were not targets, but yet we still needed a way to connect the target forms as well to a frame. But in the beginning, at least, we only had to utilize what we could with the information we had. But as we kept going and figured out more general ways to connect various frames, again, as I said earlier, with the help of overlapping columns and different information, or the same information in different tables, we were able to connect tables in new ways to get information that would solve existing problems we had. So in this way, as you see here, we connected annotation set with LU, and through that process, we were able to get the target lemma information as well.
Hello, I'm Samuel German. I worked on writing a Conlu text processing script in order to associate it with the SQL data. A Conlu data itself is a collection of morphological and syntactic annotations of text in the below manner. Specifically, it's a TSV file separating into 10 columns, and the exporting the Conlu file itself is not a challenge, but it is a challenge to associate the elements of the Conlu file with the relevant information in the SQL data, given only the ID field. And so as you can see, looking at this, the information we are annotating in the Conlu file is such morphological information such as gender, and we also make note of other aspects of the word such as its lemma and root word. So the problem itself is that given coordinates of an annotated token from the Conlu file, we want to retrieve the SQL information associated with the occurrence of the word corresponding to this token. The coordinates specifically are two numbers k and n, where k is the kth sentence in the Conlu file and n is the nth row of that sentence. So one of the difficulties with converting is, as alluded to before, the tokens for each occurrence of the word in the Conlu file don't by themselves say anything about the information for this occurrence of the word in the SQL data, in the sense that given only such a token, it is impossible to determine the token's beginning and character in its document and also it's impossible to determine other features of it, just the frame ID, the frame it evokes, given only the tokens in that Conlu. So in order to know some information, we must specifically have the SQL data, and we must apply algorithmic computational procedures to the SQL data in order to get this. Also, another difficulty is that the sentences into which the Conlu info is broken up bear no relationship to the sentences of the document being annotated. So if we know we're in the kth sentence, we cannot use that fact to search the SQL data for something corresponding to the kth sentence, as there's no relationship like that. Another difficulty is that the word corresponding to the token likely appears multiple times in the same document, so we cannot use the word occurring in a token as a basis to look through the SQL data and find the relevant data either. So the solution is to have a notion of the relative word index, which tells us the order in which a particular instance of a word appears relative to all the other occurrences of that word in the file. Such can be computed by both the SQL data and the Conlu info. Specifically, what we do is, for example, on the Conlu side, count the number of ones which appear prior to finding the exact token we want, and count them and see how that compares to the number of times the word appears prior to the token we want, and that can illuminate this notion of the relative word index. And then the SQL info, by similar iteration, can also give rise to this relative word index through computation. And what we have hereby is a means by which to associate a token from a Conlu file to a unique entry in the SQL file using the relative word index. So if we think of mapping information in the Conlu file to its relative word to the item the SQL file has the same relative word index, this is now a bijective function when you can uniquely, specifically get the information you want on the SQL side.
Hi, finally, I'll be going over the difficulties we found in using the Wikibase technology that others may need to know. One big problem we found was the Wikibase cloud had slow import speed and trouble with mass delete and refresh of item queries. What this basically means is when we would mass delete items and then use the Sparkle query, we would still see the items we deleted. It was also inconvenient to modify data once it was imported. On the local Wikibase, we had technical challenges installing it. Here's an example of a technical installation challenge we had due to another member importing large sizes of data, which essentially didn't allow us to create a new Wikibase. There was also sparse documentation on installing this Wikibase. On the WebTool and SQL data side, we found that there was limited functionality and documentation for the Wikibase, and Akkadian text is indexed by character and it was not tokenized on the Wikibase.
Hi, this is Matthew Ong again, the project director. Just wanted to add a few words at the end of this video. The work that the students did for this project is actually quite unprecedented and pioneering in the field of Assyriology. The idea of actually taking morphosyntactic annotations, semantic frame annotations, and then importing them basically into a knowledge graph format on a platform like Wikibase really is actually very exciting stuff. It offers a lot of potential for linguistic and corpus research for Assyriologists, and basically apart from the kind of difficulties that some of the members talked about, the scripts that import the data and generate all the necessary information are ready to go. It really is problems with Wikibase currently that we were working out. And you can expect in the future, probably in the short-term future, to actually see this kind of work being discussed in academic publications and talks. The students did learn quite a lot about Wikibase, about Python and SQL. So, in fact, they even came up with a number of innovative solutions to problems that I hadn't really thought about it. So they deserve a lot of kudos for that.